Article 680.22 of the National Electrical Code does address the possibility of utilizing the outside central air disconnect switch as a means to supply electrical service to new garages. However, this is contingent upon meeting specific conditions outlined in the code. Thusly, the service entrance conductor used for extending power to the garage must not be smaller in size than the existing service entrance conductor already in place for the air conditioning unit. This requirement ensures that the conductor is adequately sized to handle the potential load of both the air conditioner and the new garage without exceeding its capacity, preventing overheating and potential fire hazards. Secondly, the service panel installed within the new garage must be configured as a subpanel of the main service panel located in the house. This configuration is crucial for maintaining proper electrical protection and coordination between the two panels. A subpanel receives its power from the main service panel and provides localized circuit protection for the garage electrical circuits. Thirdly, the main service panel in the house must possess sufficient capacity to accommodate the additional electrical load imposed by the new garage. This involves evaluating the existing load on the main panel and determining whether there is enough spare capacity to handle the amperage requirements of the garage, taking into account lighting, outlets, and any appliances or equipment that may be used in the garage. A load calculation should be performed to ensure that the main panel is not overloaded. Fourthly, the subpanel installed in a new garage must be appropriately rated for the size of the service entrance conductor that feeds it. This means that the subpanel's main breaker and busbar must be capable of handling the maximum current that the service entrance conductor can carry. Using a subpanel with an inadequate rating can lead to overheating, breaker failure, and potential safety hazards. Fifthly, the subpanel in the new garage must be installed in a location that adheres to the requirements stipulated by the National Electrical Code. This includes considerations such as accessibility, working space, and protection from physical damage. The subpanel should be mounted in a location that is readily accessible for maintenance and repairs, with sufficient clearance around it to allow for safe working conditions. Additionally, the subpanel should be protected from exposure to moisture, chemicals, or other environmental factors that could damage its components. In addition to these core requirements, there are several additional considerations that should be taken into account when utilizing an air conditioning disconnect for garage power. Firstly, the outside central air disconnect switch must be clearly labeled to indicate its purpose. This labeling should clearly identify that the disconnect switch serves not only the air conditioning unit but also the electrical service to the garage. Clear labeling helps to prevent confusion and ensures that individuals working on the electrical system are aware of the multiple functions of the disconnect switch. Secondly, the service entrance conductor that feeds the garage subpanel must be protected by a fuse or circuit breaker located within the main service panel. This overcurrent protection device is essential for safeguarding the conductor against short circuits and overloads. The fuse or circuit breaker should be sized appropriately to match the capacity of the service entrance conductor and the rating of the subpanel. Thirdly, the subpanel installed in the new garage must also be protected by a fuse or circuit breaker within the subpanel itself. This provides an additional layer of protection for the branch circuits that originate from the subpanel. The fuses or circuit breakers in the subpanel should be sized appropriately to match the capacity of the individual branch circuits they protect. Fourthly, the service entrance conductor must be routed in a manner that is approved by the local electrical inspector. This includes considerations such as the type of wiring method used, the method of support and protection, and the clearances from other objects and structures. The wiring should be installed in accordance with the National Electrical Code and any applicable local codes or regulations. It is also essential to exercise caution and recognize that utilizing an air conditioning disconnect for garage power is not universally permitted by all local electrical codes. The National Electrical Code provides a general framework for electrical installations, but local jurisdictions often have their own specific requirements and interpretations of the code. Before proceeding with this type of installation, it is strongly recommended to consult with the local electrical inspector to ensure compliance with all applicable codes and regulations. The electrical inspector can provide guidance on the specific requirements in the area and ensure that the installation meets the necessary safety standards. Failing to consult with the local electrical inspector can result in code violations, fines, and the potential for unsafe electrical conditions. Ensuring that the electrical installation is compliant with all applicable codes and regulations is crucial for protecting the safety of the occupants and preventing electrical hazards. The National Electrical Code, or NEC, is a comprehensive set of standards that govern the safe installation of electrical wiring and equipment. It's important to understand that the NEC is not law itself, but rather a model code that is adopted and enforced by local jurisdictions such as cities, counties, and states. These jurisdictions may adopt the NEC as is, or they may modify it to suit their specific needs and circumstances. The primary goal of the NEC is to protect people and property from electrical hazards. It achieves this goal by establishing minimum safety requirements for electrical installations. These requirements cover a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Compliance with the NEC is essential for ensuring the safety and reliability of electrical systems. The NEC is updated every 3 years to reflect changes in technology and best practices. The update process involves a collaborative effort of electrical experts, including engineers, contractors, inspectors, and manufacturers. The NEC is organized into chapters, articles, and sections. Chapters provide a broad overview of specific topics, while articles delve into more detail on particular aspects of those topics. Sections provide specific requirements for electrical installations. The NEC uses a numbering system to identify specific sections within the code. For example, Section 210.80 refers to a specific requirement for ground fault circuit interrupter protection in dwelling units. Understanding the NEC organization and numbering system is essential for navigating the code effectively. Article 680 of the NEC specifically addresses the requirements for swimming pools, fountains, and similar installations. While the question at hand involves using an air conditioning disconnect for garage power, it's important to recognize that Article 680 primarily focuses on aquatic environments and may not directly apply to garage wiring in most situations. However, there may be some overlap in certain areas, such as grounding and bonding requirements, which are essential for ensuring electrical safety in any type of installation. When working with electrical systems, it's crucial to understand the difference between grounding and bonding. Grounding refers to the connection of electrical equipment and systems to the earth. This connection provides a low impedance path for fault current to flow back to the source, allowing overcurrent protection devices to operate and clear the fault. Bonding, on the other hand, refers to the connection of metallic parts of an electrical system to create an electrically conductive path. This path helps to minimize voltage differences between metallic parts, reducing the risk of electric shock. Both grounding and bonding are essential for electrical safety. Overcurrent protection devices, such as fuses and circuit breakers, are designed to protect electrical circuits from overload and short circuits. An overload occurs when current in a circuit exceeds the ampacity of the conductors. A short circuit occurs when there is an unintended low resistance path for current to flow, resulting in a very high current flow. Overcurrent protection devices are designed to automatically interrupt the flow of current in the event of an overload or short circuit, preventing damage to equipment and reducing the risk of fire. The ampacity of a conductor is the maximum current that the conductor can carry continuously without exceeding its temperature rating. The ampacity of a conductor depends on several factors, including the size of the conductor, the type of insulation, and the ambient temperature. The NEC provides tables that list the ampacity of various types of conductors under different conditions. It's essential to select conductors with an ampacity that is sufficient to handle the expected load in the circuit. When sizing overcurrent protection devices, it's important to consider the ampacity of the conductors and the rating of the equipment being protected. The overcurrent protection device should be sized to protect the conductors from overloads, but it should not be larger than the rating of the equipment. The NEC provides guidelines for sizing overcurrent protection devices in various situations. A subpanel is an electrical panel that is fed from another electrical panel, typically the main service panel. Subpanels are used to provide additional circuit capacity and to isolate circuits for specific purposes, such as for a garage or an addition to your house. When installing a subpanel, it's important to follow the NEC requirements for grounding, bonding, and overcurrent protection. The subpanel must be properly grounded to the grounding electrode system, and all metallic parts of the subpanel must be bonded together. The subpanel must also be protected by an overcurrent protection device in the main service panel. A load calculation is a process of determining the total electrical load that will be connected to an electrical system. Load calculations are used to size conductors, overcurrent protection devices, and electrical panels. The NEC provides guidelines for performing load calculations in various situations. When performing a load calculation, it's important to consider all of the loads that will be connected to the system, including lighting, receptacles, appliances, and equipment. It's also important to consider the demand factors that may apply to certain loads. A demand factor is a percentage that is applied to the connected load to account for the fact that not all loads will be operating at the same time. The electrical inspector is a professional who is responsible for ensuring that electrical installations comply with the NEC and other applicable codes. Electrical inspectors typically work for local jurisdictions, such as cities, counties, or states. They review electrical plans, inspect electrical installations, and issue permits. Consulting with the electrical inspector before starting an electrical project is essential for ensuring that the installation will comply with all applicable codes. The electrical inspector can provide guidance on specific requirements and can help to avoid costly mistakes. Electrical work can be dangerous, and it's important to take precautions to protect yourself from electrical shock. Always turn off the power before working on electrical circuits. Use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. If you are not comfortable working with electricity, it's best to hire a qualified electrician. Working with electricity can be dangerous, and it's important to take precautions to protect yourself from electrical shock. Firstly, always turn off the power before working on electrical circuits. This can be done by switching off the circuit breaker that supplies power to the circuit you will be working on. Secondly, use insulated tools and wear appropriate personal protective equipment, such as gloves and safety glasses. Insulated tools will help to protect you from electric shock, and safety glasses will protect your eyes from flying debris. Thirdly, if you are not comfortable working with electricity, it's best to hire a qualified electrician. A qualified electrician has the training and experience to safely perform electrical work. Before starting any electrical project, it's important to obtain the necessary permits from the local jurisdiction. Permits are required for most types of electrical work, and they help to ensure that the work is performed safely and in accordance with the NEC. To obtain a permit, you will typically need to submit a set of electrical plans to the local jurisdiction for review. The plan should show the proposed electrical work, including the location of wiring, outlets, and equipment. Once the plans have been approved, you will be issued a permit. After the electrical work has been completed, it will need to be inspected by the electrical inspector. The inspector will verify that the work has been performed in accordance with the NEC and the approved plans. If the work passes inspection, the inspector will issue a certificate of occupancy. When working with electrical wiring, it's important to use the correct type and size of wire for the application. The NEC specifies the types of wire that are permitted for various applications. The size of the wire is determined by the ampacity of the circuit. The ampacity of a circuit is the maximum current that the circuit can carry continuously without exceeding its temperature rating. When installing electrical outlets, it's important to follow the NEC requirements for spacing and location. The NEC specifies the maximum distance between outlets in various types of rooms. The NEC also specifies the location of outlets in relation to sinks, bathtubs, and other water sources. When installing electrical equipment, it's important to follow the manufacturer's instructions. The manufacturer's instructions will provide information on how to properly install and operate the equipment. It's also important to ensure that the equipment is properly grounded. Branding helps to protect against electric shock in the event of a fault. If you are unsure about any aspect of electrical work, it's best to consult with a qualified electrician. A qualified electrician can provide guidance and assistance to ensure that the work is performed safely and in accordance with the NEC. Remember that electrical work can be dangerous, and it's important to take precautions to protect yourself from electrical shock. Always turn off the power before working on electrical circuits, use insulated tools, and wear appropriate personal protective equipment. If you are not comfortable working with electricity, it's best to hire a qualified electrician. Before using an AC disconnect for garage power, remember to consult local jurisdiction, such as the City of Baltimore, and follow all rules and regulations. It is best to hire a qualified electrical contractor to complete the work.